So today we're going to cover the rational root theorem, and I'm going to be honest with you, its application can be a little tedious. It's not difficult, it's just can eat up a lot of time. So we're going to start with the rational root theorem today, and in the coming lessons we're going to learn some shortcuts that will allow us to speed up the process. But the rational root theorem looks like this. If you have a polynomial, and our polynomials come in a general form, f of x equals a sub n x to the n, and a sub 1 minus 1 times x to the n minus 1, plus all those other terms, and then you got your last variable term, a sub n, not a sub n, a sub 1, x to the 1, and a sub 0, your constant term. So if you start with a polynomial in this form, then every rational zero has to come in a specific format. Now, first of all, let's define a couple of those terms. What does it mean for a number to be rational? Ethan? Has a definite end. Okay, so if we write it as a decimal, it stops. Okay, if we look at the root word too, we should be able to get another definition for rational that might be helpful. Ingrid? We can write it as a ratio, and how do we normally see ratios written? As fractions, okay? So we're going to be looking at fractions. Okay, now we know what the number 0 is, but that's not particularly what we're looking at. What is the 0 of a polynomial? What's another term for 0? X-intercept, that's one way of looking at it. What else? What's another synonym for 0 in polynomials? Starts with an S. Alright, I'll just give it to you since you're not all jumping on it. Solution. Okay. And we learned last week with the remainder theorem that when we use synthetic substitution or synthetic division, we get a remainder of 0. So we need to remember that when we're using synthetic substitution, if we get a remainder of 0, okay, we have a 0 or a solution or an x-intercept. So that's what we're going to be looking for to happen. So when we have a polynomial, every rational 0 is in the form P over Q, where P is a factor of a sub 0, and Q is a factor of a sub n. Now, that seems pretty cumbersome to remember. So the key part that you're looking at is this right down here. Factors of a sub 0 and a sub n. And those tie all the way back to the polynomial. A sub 0 is the constant term at the end. A sub n is the lead coefficient. And so if we have a rational 0, not every polynomial has a rational 0. In other words, not every solution, not every polynomial has a solution that can be written as a fraction. Sometimes it's a weird radical. Sometimes it doesn't cross the x-axis at all, so we don't have a real solution. But if it does, it comes in the form of a factor of the constant term over the lead coefficient. So our first step today is going to be identifying all of the possible rational zeros of a polynomial. The first polynomial we're going to look at is f of x equals x cubed plus 2x squared minus 11x plus 12. So we're looking at factors of one number over another. What's the number or the factors that are going to go in the numerator? What's the term that we put in the numerator? Ethan? The actual number. 12. We're going to be looking at factors of 12. So I'll write that just to be clear. Factors of 12 over factors of what number? What's going to be in the denominator? Christian? Which is 1 in this case. The leading coefficient, which in this case is 1. So first thing I want to do is list all of the factors of 12. What numbers go into 12 evenly? Ingrid, you just give me the first one. 1. Tori, how about the next one? Christian. Sarah. Ethan. Lily. 12. The nice thing about the factors is they're symmetric. Okay? In other words, 3 times 4 equals 12. 2 times 6 equals 12. 1 times 12 equals 12. Okay, so you got to have a pair there. Okay? Are there any other numbers that go evenly into 12? Okay, you're right and you're wrong, but we'll get to that in a second. How about factors of the denominator? Nate, what are all the factors of 1? Way to go. Okay, now the good news is that is all of the positive numbers that go into 12. The bad news is that's only half of the factors of 12. Now, based on what I just said, can you tell me, Sarah, what might be the other half? All the negatives. Because negative 1 goes into 12, negative 12 times, and negative 2 goes into 12, negative 6 times. And so each of these needs a little plus or minus attached to it. Now the good news is when our lead coefficient is 1, breaking this down into the actual terms is real easy because when we divide 1 by 1 we just get 1. And so plus or minus 1 divided by plus or minus 1 is just plus or minus 1. And plus or minus 2 divided by plus or minus 1 is just plus or minus 2. So it's real simple when our lead coefficient is 1 to keep track of all of our possible factors. So that is all our possible rational zeros for that polynomial. In other words, if it crosses the x-axis at a rational number, it has to be one of those 12 numbers. Everybody okay with that? Okay. Let's do another one. Let's change that lead coefficient. So in the numerator, we need factors of what number, Antonio? 10. And in the denominator, Ingrid? Alright, so let's go through the factors. Tori, what's the first factor of 10? I'm sorry? 1. And we're going to just attach the plus or minus while we're going. What's the next one, Christian? Sarah? Ethan? Okay, that's all the factors of 10. Now we look at the denominator. We need to cover the factors of 4. What's the first one, Lily?
2.
Okay, I'm going to call it the first one, but that'll work. Nate? And Sarah? 4. So now we have to cover all of the possible fractions out of all those combinations. And this is where it gets really tedious. Because we can have, as a numerator, 1 and a denominator of 1. So we could have plus or minus 1 over 1, which is 1. And we can have plus or minus 1 over 2. And we can have plus or minus 1 over 4. Okay? That takes care of this one. Then we have plus or minus 2 over 1, plus or minus 2 over 2, and plus or minus 2 over 4. That takes care of this one. Now we have plus or minus 5 over 1, plus or minus 5 over 2, and plus or minus 5 over 4. Takes care of this one. We have plus or minus 10 over 1, plus or minus 10 over 2, and plus or minus 10 over 4. Anybody notice anything interesting? Besides the fact that that's a pretty long list. Yeah. Some of them are the same number. And so we can, as we go through and simplify those fractions, we can eliminate some of those. So we're not going to catch any in the first round. Plus or minus 1, plus or minus 1/2, plus or minus 1/4. Plus or minus 2 over 1 is just 2. What about plus or minus 2 over 2? Is that a duplicate or not, Tori? Yeah, it's just equal to 1. So that one's already covered. How about 2 over 4, Christian? 1/2, so it's already covered. Okay. We got 5 over 1. Is that a duplicate, Sarah? Nope, that's just 5. How about 5 over 2, Ethan? Is that a duplicate? No. 5 over 4, Lily. Have we covered that one yet? Nope. Nate, 10 over 1? No, we could just list that as 10. Now, what about 10 over 2, Sarah? Is that a duplicate? What is it? 5. And what about 10 over 4? Yeah, same as 5 over 2. Okay, so that cuts our list down a little bit. So all of the possible rational roots, or rational zeros, are right there. It's exciting, isn't it, Tori? Alright, now I'm going to give you a chance to come up with your own list. It's very exciting. So I'm going to give you this polynomial. I'm going to give you a second to come up with all the numbers, and we'll see if we have them all covered when we're done. So your polynomial is 2x cubed plus 3x squared minus 11x minus 6. So use that process, come up with your list of all the possible rational zeros, and we'll see if we get them all together. Alright, so Ingrid, what's the first set you have? Plus or minus? Okay. Tori? What do you got? Plus or minus 1/2. Christian, give me a pair. Ooh. Let's think. 1 over 3. That would mean that I've got a 3 in the denominator. My denominator is factors of 2, right? Okay. 3 doesn't go into 2, so that one can't work. Do you just have it upside down? 3 over 1. What does that reduce to? Just 3. There you go. Sarah, what do you have? 6. Okay, Ethan? Plus or minus 2. Lily?
Plus or minus 3.
Okay, the last 3 of you there, do you have any that they didn't have? Do they have any that you didn't have? No? Okay. That should be all 6 pairs, okay? Because factors of 6 are 1, 2, 3, and 6. Factors of 2 are 1 and 2, okay? The 6 over 2 is going to end up being a duplicate with 3. The 2 over 2 is going to be a duplicate with 1, so that starts to narrow them down a little bit. Okay. Alright, the last thing we're going to cover, one more type of problem, is how to find all the zeros when the leading coefficient is 1, which isn't any different than if the leading coefficient is not 1. It's really just shorter because you have less possible zeros. So this isn't something we know how to factor. This isn't a polynomial that we could factor by grouping. You could try, but you won't find anything that works. So we're going to use our rational root theorem to find a solution and then use that solution to find other solutions. Now there's good and bad news with this. The good news is once we find one solution, that narrows down our list of possible rational zeros. The problem is we have to start by just guessing numbers and seeing which one will give us a workable solution. Now, to avoid cheating, I want you all to close your books. This is where it gets super fun. So first of all, let's list our possible rational roots. What type of factors are in the numerator, Nate? Factors of what number? 20. And the denominator, factors of what number, Sarah? 1. Okay. So, Antonio, can you give me all the factors of 20? 1, 2, 4, 5, 10, and 20. Now, the nice thing is, since our denominator is factors of 1, the only factor of 1 is 1, and anything divided by 1 is itself. So, there's really no simplifying to do. Those are all our possible factors. So, we have a total of 12 possibilities, and we've got to find which one are possible factors. Now, here's the thing. If all of the roots of this equation are rational, there's still only going to be 3 because you can never have more roots or more zeros than the degree. So we got 20 possibilities. No more than 3 of those numbers are actually roots or actually zeros. We have to figure out which one or ones. That sounds really fun, right? So we're going to use synthetic substitution, and we'll know that we have it if our remainder is what number? 0. Okay? So if we give our... I know, she answered. I pointed at you, she answered. We'll just skip her next time. Or maybe we'll skip you because and we'll make her go twice. So we're going to use synthetic substitution. We're going to put our coefficients up there. 1, -8, 11, and 20. We have no missing numbers, so no zeros to fill in. And we're going to be doing this several times because we got to figure out which number we're going to plug in to get our solution. So Tori, pick one of those 12 numbers. Because you're next in line. That's why you. 1. Okay, let's try 1. Okay, first number to go down is 1. What's the next number, Christian? Sarah. Add. -7. Okay. Ethan? Lily?
4.
Nate? Sarah? So is that a solution? Is that a 0? Nope, it's not +1. Okay, so we can kill the +1. Now we got to try it with another number. Alright, Antonio, give it a shot. Oh, he's going to try -1. That makes sense, right? 1 didn't work, we'll try -1. We'll just work our way down the line. Alright, so next number. Ingrid, 1 is obviously the first. Next number is? Tori? Christian? Sarah? I'm sorry? 20? Ethan? Lily? 0! Yay! -1 works. I feel like he cheated. I feel like he stole it from the book before we closed the book. He probably did, right? Alright. Now, the good news is, and there is good news here, this means if x equals -1 is a 0, that means that x plus 1 was a factor. Remember, that was the factor theorem that we learned last week. And if we factor out x plus 1 from f of x, what's left over? I don't remember where we left off. Oh, we left off on Ethan. So, Lily, do you remember what's left over? Yep. So what variables do those get attached to? Do you remember?
X squared minus 9x plus 20.
Exactly. Nice. Now, the good news is that is a quadratic, and we know how to solve a quadratic in several different ways. We can factor, we can use quadratic formula, we can complete the square, all sorts of options to find our other solutions. In other words, once we've got it down to a quadratic or anything else that we can factor, we don't have to go through this big list up here to find our solutions. Okay? The bad news is if you start with like a degree 5 polynomial, then that's like 3 zeros you've got to go through in order to get there. So, who knows what factors of positive 20 add up to negative 9? I think we're on Nate. Negative 4 and negative 5. So that quadratic factors into x minus 4 and x minus 5. So you're applying some processes that we learned with the factor theorem and the remainder theorem along with the rational root theorem. So Sarah, what are our zeros? 4 and 5. Right, because we take x plus 1 equal to 0, x minus 4 equal to 0, and x minus 5 equal to 0, and solve each of those, and we have all 3 of our zeros. We know there can't be more than that because it's a third degree polynomial. Are there any questions? Okay, tomorrow we're going to take this a little further with slightly larger polynomials with more complex possibilities for our zeros, and learn how to limit our options after the first and second steps.